All right, we're finally at the end. So we are now going to look at the last type of identities that you will be responsible for, and these are the half angle identities. So they are along the same train as the sum and difference identities, kind of the cofunction identities, the double angle identities, and the half angle identities. They could be used to simplify or find an exact value of an angle that you don't know the exact value of. So the first skill that you have to learn is how to write a half angle identities. So what it is that if you have an angle like 15 degrees, we learned with sum and difference identities that, for example, if it was the sine of 15, we could write it as the sine of 60 minus the sine of 45, right? And that would give us the sine of 15. Well, this is giving us another option. Instead of writing it as a sum or difference, we could write it as a half angle, meaning that if I were to double 15, I get 30. So 30 degrees divided by 2 is the exact same as 15 degrees. And what we're going to be able to do is change the way that the trig function is written so that everything will be in terms of 30 degrees instead of 15 degrees. So same thing in radians. People have a harder time doing this. So I thought of kind of an intermediate step, right? So what I want you to do is write 8 as 2 times something. So 8, for example, is 2 times 4. So what happens is that x divided by 2 and 4 can be written as pi divided by 2 and 4 can be written as pi divided by 4 n divided by 2. So what we're doing is you're going to take half of the 8 and you're going to show that we're taking half of that. Okay, so what does that mean? Well, if we have an angle like 22.5, 22.5 is what divided by 2? So you take 22.5 and you times it by 2 and you get 45 degrees. Ah, oh, there's an exact angle, I know. So same thing with 112.5. You go 112.5 times 2 and you end up with 225. 225 is an angle I know because it's 45 degrees past 80. Okay. So then let's do the ones with radians. So again, I kind of thought of this intermediate step that you would write it as 12 is 2 times 6. So then you'd write it as 5 pi by 6 by 2. And again, 5 pi by 6 is pi by 6 away from 6 pi by 6, right? So pi by 6 is one of our known identities, or our known angles. Okay, so same thing here. This would be 7 pi by 4 by 2, because 7 pi by 2 by 4, we can just write as 7 pi by 4 by 2. All right, so let's see how we're going to use this. So as always, I try to give you some sort of a process. So the first thing we're going to do is rewrite the angle as some angle divided by 2. So for this one, I would write it as the sine of 30 degrees divided by 2. Then we're going to use the appropriate half angle identity to solve using special triangle angles. So then we're going to go to our formula sheet, and you'll notice we've done everything. We've done basic identities, Pythagorean identities, sum and difference identities, cofunction identities, double angle identities, and here we are at the end in half angle identities. So it says that the sine of any angle divided by 2 is equal to plus or minus, which we'll talk about in a sec, the square root of 1 minus the cos of the angle. So whatever angle's on top in this half angle identity is what goes in here, and then the whole thing divided by 2. So let's ignore the sign for a second, and let's just rewrite this as the square root of 1 minus cos 30 divided by 2. Okay, so the square root of 1 minus cos, the top angle, which is 30, all divided by 2. Okay, so we've rewritten as a half angle. We've used the appropriate half angle identity to solve using special triangles. But the third thing we do is we have to decide whether the answer is positive or negative. So the formula had it as the sine of x over 2 is equal to plus or minus the square root of 1 minus cos x over 2. You have to decide whether it's plus or minus. So that's all depending on where angle 15 is. So since angle 15 is in the first quadrant, everything is positive. So we are going to choose, I'm going to put it in red because everybody forgets it, we are going to choose positive. Okay, so it's up to us to decide what our answer is going to be, positive or negative, depending upon which quadrant the original angle is in. Okay, and then from there, it's just using special triangles. So we just have to evaluate the cos of 30. So 30 degrees is here. It's the 1, 2, root 3 triangle. Everything's positive, so it would be adjacent over hypotenuse. So I can drop my positive, and we go 1 minus adjacent is root 3 over hypotenuse, which is 2, all over 2. Okay, so you can't leave things in like an improper form. So we don't like the fact that this is a compound or a complex fraction. So we're going to make it not be. So the way that we're going to do that is we're going to multiply by 1. So I'm going to multiply the top and the bottom by 2. So I've kind of switched, you'll notice in some notes I would create a common denominator and say, okay, this is the numerator divided by the denominator, and I'd flip and multiply. Some people do it that way. Some people destroy that compound or that complex fraction, right? They multiply through by 2. So if I multiply through by 2, I would end up with, I'm going to go up here because I know I have a bit more to write. I would end up with the square root of 2 minus, now root 3 over 2 times 2 would leave me with just root 3, all over 2 times 2 is 4. Then I'm going to rewrite that as the square root of 2 minus root 3 all over the square root of 4, which is 2. So this is my final answer. Now, something I've been forgetting to mention in these videos is that you can always check to make sure you're right. What we've given is the exact solution, which you can only get if you go through this process. But your calculator is perfectly capable of coming up with a decimal solution. So if I plugged into my calculator, make sure my calculator is in degrees, if I plugged into my calculator the sine of 15, I get 0.258819045. If I take this into my calculator and I go the square root of bracket 2 minus root 3 bracket, and then I equal, so I get my numerator, and I take that and I divide by 2, I also get 0.258819045. So it's a way to check to make sure that you've done it correctly. And I do this all the time with these because I never trust myself, especially with choosing the plus minus. I don't know. So it's always good to check. All right, so let's do one with radians, and then I've got 2 for you to try. So tan of 5 pi by 8, the first thing I'm going to do is write that as a half angle identity. So in other words, it's what divided by 2. So it's 5 pi by 4 divided by 2. Okay, and then I go to my formula sheet and I find my half angle identity. So we go in here and I'm looking for tan. Now tan, as always, has multiple options. I mean, I guess not as always, but it usually does. So the tan of x over 2 is equal to these 3. So I can use any of them, but what I'm going to think is there's no way I want to include a square root, right? There's just no way. And so what I'm going to do is I'm going to use this third one. I'm going to use 1 minus cos x over sine x. So I'm going to go back over to my note, and it was 1 minus cos of x, which is 5 pi by 4, over sine of 5 pi by 4. Okay, now this one you'll notice didn't have the plus minus in front, so you don't have to be responsible for the plus minus, right? It'll just come out to the right sign. If you did though, I just want to point out, right, because it's going to come up in one of these two, is that if you were looking at 5 pi by 8, so it's past pi by 2. Right? Pi by 2 would be 4 pi by 8, so it's in quadrant 2, C-A-S-T. So if you had to choose, I know that my answer is going to come out as negative because tan is negative in the second quadrant. But this one should just work out for you because it involves the sine and the cosine. It does the sine for you. So we just have to evaluate. So looking at this one, I've got the cos of 5 pi by 4. So 5 pi by 4 is in quadrant 3. My reference angle is pi by 4 past 4 pi by 4. So I know I've got my 1, 1, root 2 triangle. I always have to look for my signs, the negative x value and a negative y value. Okay, and then we plug it in. So we get 1 minus the cos. Now cos of 5 pi by 4 is adjacent over hypotenuse. I'm going to rationalize it before I put it in. It's so much easier. So negative root 2 over 2. So I'm going to put in negative root 2 over 2. And then in my denominator, I've got sine of pi by 4. Now sine of pi by 4 is the same, negative 1 over root 2. So I'm going to put in negative root 2 over 2. Okay, so now the next thing I'm going to do is I'm going to, what do I want to do next? I can do multiple things, right? I can simplify my numerator. I think what I'm going to do is multiply to get rid of the compound fraction. So I'm going to multiply by 2 over 2. 2 over 2. So I'm going to multiply the numerator by 2 and the denominator by 2. And I'm going to end up with 1 times 2 is 2. Now this is take away negative, so I'm going to put plus, and then 2 divided by 2 is gone, root 2. All over 2 times 2 is gone, negative root 2. And would it be nice if we were done at this point? But we're not, because you always have to rationalize your denominator. So I'm going to multiply by the radical in the denominator. Now, personally, I also don't like that there's a negative in the denominator. So I'm going to multiply by negative root 2. What's going to happen is I'm going to end up with 2 times negative root 2. So I'm going to end up with negative 2 root 2. And then negative root 2 times positive root 2 is minus 2. All over negative times a negative is a positive. Root 2 times root 2 is 2. Okay, so there's an answer, but I can simplify this. Oh man, it keeps going. So I'm going to pull out a 2 to be left with negative root 2 minus 1. Now I know this rule is that you usually would pull out a negative 2, but I can't simplify with a negative 2, so I'm not going to pull it out. Over 2, and then that would simplify to negative root 2 minus 1. Okay, so again, to check this, make sure your calculator's in radians, plug in the tan of 5 pi by 8, get an answer, and then also do that with negative root 2 minus 1, and you should get the same answer. All right, so I want you to pause the video, and I want you to give these two a try. So hopefully you paused the video and you gave these ones a go. So we've got cos of 165, which is equivalent to the cos of, so we're going to take 165 and multiply by 2, and we get 330. So the cos of 330 degrees divided by 2. Okay, so then we go to our identity page and we pull out the proper identity. So the cos of x over 2 is equal to plus or minus, there's that plus or minus thing again, 1 plus cos x over 2. So 1 plus the cos of 330 divided by 2. Okay, so step number 1 we wrote as a half angle identity. Step number 2 we rearranged it into the half angle identity, but now we have to decide plus or minus. So we look at it, CAST, 165 is in quadrant 2, so I know that I am going to make this negative. Okay, now we go in and we evaluate what we can. So we've got negative the square root of 1 plus. I'm trying to evaluate 330. So 330 is in quadrant 4. It's 30 degrees away from 360. So 1, 2, root 3 triangle. Because the y value is in a negative direction, it's a negative 1. So then the value of cos of 330 is adjacent over hypotenuse, which is root 3 over 2, all over 2. Now I'm going to clear that complex or that compound fraction by multiplying by 2 over 2. And that's going to give me negative the square root of 2, because I'm expanding that 2 through, plus root 3 all over 4. Then I'm going to rewrite that so that it's a radical divided by a radical, so negative the square root of 2 plus root 3 all over the square root of 4, which is 2. And again, if you plug cos of 165 into your calculator and you plug this into your calculator, you should get the same value. All right, last one, sine of pi by 8. So sine of pi by 8 is equal to the sine of pi by 4 divided by 2. So then we go to our identity page. We pull out the proper half angle identity. So it's 1 minus cos x over 2. So square root of 1 minus cos, the x value is pi by 4, divided by 2. I have to decide whether it's plus minus. So I look at pi by 8 is in quadrant 1. Everything is positive. So I'm choosing the positive radical. Okay, then I evaluate. I've got 1 minus the cos of pi by 2. Maybe some of you start having these memorized. Sorry, pi by 4. Pi by 4 is in quadrant 1. I've got a 1, 1, root 2 triangle. Everything's positive. The cos of pi by 4 is adjacent over hypotenuse. Rationalize the denominator, and I get root 2 over 2. So I'm going to go 1 minus root 2 over 2 all over 2. And once you do enough of these, I mean, they're so scary at first, but this one, I mean, sure, it's root 2 over 2 instead of root 3 over 2, but it's exactly the same. So it ends up being repetitive. You just have to do enough of these until they become repetitive. Okay, now I'm going to clear that compound fraction by multiplying by 1. I would end up with the square root of 2 minus root 2 all over 4, which is going to give me the square root of 2 minus root 2 all over the square root of 4, which is 2. Whew. All right, so the last thing, you know, you could go and practice these and watch the end of this video, but the last thing I wanted to show you is that sometimes you're not going to just be evaluating using these identities. So up until now, like double angle identities and half angle identities have been mainly used to evaluate, but they could appear in an identity coming up. In other words, they could be appearing in a way that you need to simplify using them. So let's look at two examples that we are going to simplify using the double and half angle identities. So the first one we're going to look at is sine x plus cos x all squared. So I would want you to write this as the sine of x plus the cos of x times the sine of x plus the cos of x. Now everything's in sines and cosines, so I don't have to use my basic identities. I'm just going to distribute. So sine x times sine x is sine squared x. Sine x times cos x is sine x cos x. Cos x times sine x is cos x sine x, but I'm going to write it as sine x cos x because it's just easier. And then cos x times cos x is cos squared x. Okay, what can I do? Well, hopefully you're spotting this glaring identity. The sine squared x plus cos squared x, it's been a while since we've looked at those, is equal to 1 plus, now I've got sine x cos x plus sine x cos x. I've got 2 sine x cos x. Now, is that simplified enough? Maybe, but you should be able to recognize that you have another glaring identity, which is 2 sine x cos x, which could be written as 1 plus sine 2x. Whew. All right, number 2. Number 2 is asking you to simplify this crazy looking thing. So when I see something like that, I'm thinking, okay, what can I do to make this simpler? Well, in here I have a half angle identity. I have an x divided by 2. So this would be 2 times sine of x over 2 all squared, right? So remember, anytime you have a trig something squared, it's that entire function is squared plus cos x. So now I'm going to look at my identity sheet for my half angle identities. I see that the sine of x over 2 is equal to plus or minus the square root of 1 minus cos x over 2. Well, the nice thing is that even though it's a square root, it's going to get squared. So it's going to get rid of the square root. So it actually doesn't matter whether it was a plus or minus, right? Because when you square it, it's going to become positive. Now I've forgotten what the rest of the identity is. It was 1 minus cos x over 2. So we've got 1 minus cos x over 2 plus cos x. All right, so now I've gotten rid of the thing that was funky. I've made it just into like an x function, and now I can do it. So I've got 2 times, now I'm taking the square of a square root. So I'm just left with, oops, not -1. I'm left with 1 minus cos x all over 2 plus cos x. All right, well, it's nice that they gave me 2 divided by 2 so that I can go boom, boom. I'm left with 1 minus cos x plus cos x, and it simplifies to 1. Now I could check, I can put an angle in for x and plug it into here, and I should get 1, and that's how I'll know I've simplified it correctly. But you can also be checking your answers in the back of the book. All right, good luck with 7.2.